Hey guys, this is Patrick from STH, and today we are going to cover all that you need to know about the major design philosophies and ideologies of the big chip makers for their server CPUs in late 2022 to early 2023, or all the way through 2023. You may have heard a lot about ARM server CPUs and even client CPUs recently. We're going to talk about what they are doing and what the vendors that are building ARM-based CPUs are doing. We're also going to talk about what Intel is doing because it is completely different, and in a lot of ways it's actually the opposite of what ARM is doing, or like what ARM was trying to do 10 plus years ago. And so that's kind of crazy. And then we're also going to talk about where AMD falls on that spectrum. And then not only are we going to talk about what the design philosophies are and how those are going to be implemented in different chips, but we're also going to discuss why that matters for even if you're buying kind of the lower end systems. Maybe you're not even buying the top end, maximum core count systems, but this new ideology and these design philosophies are going to impact you in a way that is very different from any of the server like chip generations that we've been seeing for years. If you grew up in the Xeon E5 generation, perhaps, then this is going to be completely different than what you're used to, because Intel is going to be doing something completely different, and there are other players in the market. Now, longtime STH readers and those of you on YouTube will know that a lot of times during the summer things slow down a little bit at STH because there tend not to be a ton of product launches over the summer. But I do like to take this break in our busy schedule to do things like catch up on our networking, our Tiny Mini Micro and Mini PC series, and then also I really do like to go and do these kind of just thought pieces. This is definitely a discussion piece, so if you think of something, feel free to go put those in the comments down below. Also, feel free to just share this piece with some of your coworkers and talk about it over a Zoom call, over coffee, lunch, whatever it is. Because the last pieces that we've done, like last year as an example, we did the gigabyte era of CPUs, and look where we are now. We have basically Milan-X, which is just shy of that gigabyte of cache, but we're gonna see with the next generation Genoa-X that will be in the gigabyte class, and then also Sapphire Rapids HBM. We have pictures on the STH main site with me and that chip. I mean, that will be a multi-gigabyte chip. So, that has definitely come to fruition, like the video that we did on that. We also did a piece on the DPU IPU thing really early, and we talked about, what the differences are between them and all that kind of stuff. And now we've actually started to test them, and the DPU IPU market is absolutely crazy hot right now. And so that has definitely come true. Also, CXL is just about to start taking off, and so that's about to happen. And so these are really videos that I just like to get to do. They're not really like super hands-on hardware, but on the other hand, they are ultra important because frankly you need to know about this stuff. And before we get too far in this, I just want to let you know that we don't really have a lot of b-roll or anything like that for this, so this one is kind of more like a podcast or something that you can just throw in the background, and if you want to just leave it in the background and listen to it, that's kind of more of the idea of this video. It's not necessarily, we're not going to like show you any new hardware that we haven't shown you before. So with that, I want to introduce my framework for the next 18 to 24 months of server CPUs between ARM, Intel, and AMD. And I'm going to make this not proper English, but we are going to say that the ARM is basically more cores, more better. Intel is more accelerators, more better. And AMD is kind of more medium, is more better. Okay, so the first one that I want to talk about is ARM. ARM has a lot of momentum right now, and you're going to see things that it used to be that, like, the big ARM chip was really like the Huawei Companywide 920, and that chip has been very hard to get in the US. I can now tell you that I'm re-recording this video, and yes, we do have some chips now, so that is in a system to actually run those. So we will have a review of that. I think it'll probably be the first review in the US because it took me like 2 weeks to import the thing. But after Huawei, the really big one is, let's face it, is Ampere. There are two big chips. I mean, really right now, you're either Ampere or your AWS Graviton 3. Now, we did see that the new Alibaba chip is going to be coming out, and that I think will be available in the Alibaba cloud in, I think, September, and that definitely is an interesting chip, and we'll talk about it soon. But right now, I mean, as the market stands, you're basically either going to be on like Graviton 3 or you're going to be on an Ampere-based product. Now, all of the ARM vendors try doing the exact same thing, and it is absolutely, well, understandable, but it's also mind-numbing to me. And that is, they try comparing their CPUs directly to x86 CPUs. It is not what they're trying to sell it as. It's not why cloud providers are trying to buy these things. I mean, the idea of just comparing straight away from an ARM processor today to an x86 processor is just frankly silly, but I guess that's just all we have to do, and people have to talk about something. So that's what happens. But realistically, the vast majority of ARM processors today are really focused on a single metric, and that is providing the best and most consistent vCPU performance that they can. And for vCPU, we're just going to say whatever kind of cloud vendor you have, there's some kind of compute metric, like, CPU compute metric, and that's really the metric that folks are trying to hit. And what basically happens is that the cloud providers say, hey, we need, on this benchmark suite or like whatever, this set of tests, we need this level of performance per vCPU, and we want it to be as consistent as possible. So that way, the more folks and the higher utilization we get from our hardware because we're cloud providers, those are basically, that's the performance profile we want to maintain so everybody has the same experience. So when it comes down to it, if you know the difference between the Intel P core and E core, the performance versus the efficient core, a lot of the ARM cores today are actually probably closer to the Intel E cores, right? The efficient cores. And that makes a lot of sense, right? The efficient cores don't have things like SMT, so they don't have hyperthreading. And that means that they are one core, one thread. And that's exactly what a lot of the ARM vendors are focused on these days. They also don't necessarily have all of the same acceleration and the provisions for a lot of the high-end acceleration that some of the performance cores has. And they're not trying to hit like 5 gigahertz or something. And so what the ARM vendors try to do is they basically say, okay, we are going to go use the best TSMC process, usually TSMC, but the best process we possibly can to go and make our chips, which means that they are smaller, they're more power efficient, and we can make them denser. We can put more cores on a chip. Again, more cores, more better. And so the current generation Ampere Ultra Mac, well, that chip is actually up to 128 cores. Remember, this is at a time when the top-end Ice Lake CPUs, those things are only at 40 cores. The AMD EPYC are at 64 cores. The big difference, of course, and if those numbers seem way off, is just because those chips are really looking at using SMT, and so they are really kind of thinking like you should be comparing threads to cores, and then you get a lot closer. Now, the Ampere Ultra Max has now been adopted by the Microsoft Azure Cloud, Google Cloud Platform. Oracle, I think, was the first one to go use it, but they're actually not using the 128 core versions. They're actually using just the regular Ultras, which I think is actually kind of interesting. We'll talk a little bit about that in a bit. But the whole idea is that they're basically trying to get these chips that can use a pretty minimal amount of power, but provide enough bandwidth, enough cores and compute resources, so that way the major cloud providers can provision up the chips and say, okay, each customer, you get this portion of the chip, and this is going to be our ARM solution, and that works pretty well. In terms of workloads, frankly, the cloud providers are not trying to cover with these chips the same breadth of workloads right now as somebody like an Intel is trying to do with their Xeon scalable processors. Instead, what they're really focused on is things that are really optimized for ARM. And the things that are optimized for ARM, if you have like an NGINX web server, you have like a Redis server or something like that, and you don't have to deal with per core licensing, because on a per core basis, an E core is not going to beat a P core. So anything that's like an enterprise application where you really want to have the maximum performance per core, you don't want ARM at this point. That's just kind of what it is. But for all of those applications, like if you're just running a web server, if you are a cloud provider and you just want to say, okay, how many vCPUs can I have with consistent performance at the lowest operational cost? The Ampere Ultra is 100% designed for that kind of workload. Like if you want to go run NGINX, like let's go do it. Like this is awesome, right? And so if you look at what AWS is doing with Graviton 3, they have a 64 core processor, but they're basically trying to go and put 3 of those onto a motherboard and put that into a chassis, and then that gives them more density, and that's why they're happy. They also don't have to deal with things like the NUMA performance. So if you go from like one CPU to the other CPU and you have to pass data between memory and and all that kind of stuff, you don't have to go do that if you have single socket solutions. And so that's really why I think AWS is going that route. It simplifies the design quite a bit. And a lot of the other cloud vendors are doing something similar. I mean, we saw Google say, hey, we're actually going to base our solution on 64 core Ampere Ultra, even though 128s are available, because I think that's what they saw as the right SKU for like getting that consistent performance for their users, and also because that's what Amazon does. But that's really the server chips that are today, and I would put the Alibaba cloud chip in there as well, as that's another one that's 64 core, but it is using PCIe Gen 5, DDR5, all that kind of stuff. So it is kind of next gen, but it's also 64 cores, and it'll be available in September. But that's kind of stuff that we already know. What are we going to look at in the future? And there, I think the big thing is really, if you look at like Ampere and where they're going with their chips, I mean, they're going to get a new TSMC process. And once they get a new TSMC process, plus the fact that they are going to be designing their own core, so they're not just going to use ARM Neoverse, just kind of like standard cores. What they're going to do is they're going to go and figure out how to go put more cores onto a chip, because more cores, more better. The more cores that you can put on a chip means that you get more cores in a chassis and in a server, and the more cores that you get in a server means that you're not spending as much on the rest of the server, and so you get those consolidation benefits from a cost perspective, and that is one of the big drivers that they have. And also, frankly, I think that Ampere is looking at this like, hey, we don't actually, I mean, they're going to say, of course, that they're trying to compete with Intel, but they're really like, focused on what's that maximum vCPU I can, how many vCPUs that I can get at X level performance that meets the cloud provider specs. I mean, what can I go design that hits that? And, the cloud providers are not trying to sell you like every single instance, like the instance that runs Nginx and your web server. They don't want that. They don't need that to go, and I mean, they have enough workloads. They don't need that to go do high performance computing. And so there's a lot of optimization that you can do by saying like, hey, our chips don't have to be superior at high performance computing. They don't have to be that general. I mean, they may still be able to do stuff, but we don't need to optimize for that. We can just optimize for these just kind of general purpose integer work. And the fact is that there are so many of those big workloads and the market's so big now that you can actually have players that are optimized for that. We'll talk a little bit about what Intel and AMD are going to do in that market, but that's really the idea behind a lot of the ARM vendors. More cores, more better, or basically more density, more better. Now, what Intel is doing is what I call more accelerators, more better, because the Intel Sapphire Rapids 4th generation Intel Xeon scalable processors, well, I mean, those things, they're probably delayed. Let's just call it what it is. But at the same time, Intel's actually been talking a lot about some of the features that are going to go in there. Intel has things that they've talked about, like the Intel Data Streaming Accelerator. They've talked about their AI extensions. And then also they've talked about things like Quick Assist. At STH, we are going to be having a series on Quick Assist to get you ready for that. And so we have that. It's already recorded, but hopefully it'll come out. The first one will come out later this month. But I just wanted to kind of talk about that in terms of what Intel's design philosophy is. Now, Intel is going to move to a chiplet architecture with this one. And if you're buying a server, you probably don't frankly care about the fact that there's chiplets. What you do care about is the fact that we also are going to get DDR5, we're going to get PCIe Gen 5, we're going to get a ton of accelerators. And so the way that Intel is building their chips, and why I say more accelerators, more better, is because there are certain things that are in, workloads that you just kind of commonly see that actually, the general purpose cores are just not the right answer for anymore. And an example of that, we've already looked at a couple of times, right? We've looked at things like what happens even on the Ice Lake generation when you do things like AI inference, and what's the difference between AI inference and like how much faster, what the lower latency, the better throughput is. We looked at that when we looked at the Ice Lake processors, and so we've already done that, and we'll have videos on that we'll link in the description. We've also done that with things like crypto and compression. So for example, when we talk about Nginx servers, well, an Nginx server, that can be very fast, but a lot of those Nginx servers are tested with HTTP, not HTTPS, when they're going for their Halo numbers. And the reason for that is that doing the HTTPS and actually doing all the cryptography and all the encryption stuff, that actually can introduce some variability. And because that can introduce some variability, you do want to go and offload that, because an accelerator, a dedicated accelerator, is usually much faster. So Intel's accelerator for that is really called Quick Assist. And Quick Assist, there are cards. It's in the Ice Lake D part. They've already said that there's going to be a version of Quick Assist that will be, featured in Sapphire Rapids. They've also said that Quick Assist is the underpinnings behind their IPU or DPU Mount Evans. And so that's what Google Cloud Platform is going to use. And so there's a whole bunch of different things that are going to be using Quick Assist. And it actually is surprisingly used in more places than I knew. And I just learned a lot about where it actually is pretty popular. But the fact of the matter is that when we're going to show you this in a couple weeks, just the difference between what happens when you hit that Quick Assist and you don't, I mean, it's absolutely massive. I mean, it's not like you save you get 4 cores better performance. I mean, you get like dozens of cores better performance when you hit the accelerators, right? So it's one of those things that when Intel, and people say that Intel has X number of cores and that's so much less. The other thing to remember is that Intel is kind of going after a different market, right? Intel has the HPC acceleration. There's even HBM parts with high bandwidth memory that is going to be, many, many gigabytes on the chip. I've taken pictures with these things, but I mean, like that is something that is really designed for the HPC space, and some folks that really need that kind of high bandwidth memory. They also have all the things like AVX 512. They have the machine learning stuff. They have offloads. So these are all things that basically the way to think about them is that each core in an Intel part, because it has access to on-chip acceleration and all these other things, is not just more general purpose, but it's also more performant in a wider variety of workloads. Also, the other thing to look out is that Intel will go and say hey, look at our awesome crypto performance when we just use the accelerator, but realistically a Nginx like workload, like we'll do like WordPress, and so we'll have like our database, and then we'll go into PHP FPM, we'll have Nginx, and then we'll go and we'll do the encryption on that, right? And so it ends up being that the encryption is like, I don't know, 10% of the workload, but you do see a really nice performance improvement just by using those accelerators. So the big thing to remember is that Intel, for the current or next generation Sapphire Rapids, they are thinking more accelerators, more better. And why I personally find this absolutely hilarious, and I don't know about you guys, but if you remember back to like 2010 or 2011, 2012, something like that, basically the idea was, oh, there's going to be ARM servers. And the ARM cores back then, they were not good, right? They were not fast in any way. The chips tended to be pretty small. And I mean, you know, frankly, like the ARM server industry has progressed a lot in the last 10 plus years. But Intel was worried at that point that like, hey, these ARM cores that have these amazing accelerators attached to them, I know, those things are going to take the market. So we had to go put out a new chip. And that's when we got Aviton and Rangeley, the Atom C2000 series. That was actually not the first generation. I just found that out recently. I had no idea. But that was like the first like kind of major commercial implementation that we really saw publicly on Quick Assist, and that really helped a lot of guys. I mean, if you're doing like, you know, VPN or something like that, using that Quick Assist was great. The other thing Quick Assist was really used for is a lot of the storage platforms use that as their compression, you know, instead of coming up with like a custom ASIC or something like that, they just use Intel Quick Assist. And so that's why a lot of storage platforms, even if you say like, hey, why are they not AMD? Why are they Intel? One of the reasons is because of Quick Assist. So like 10 years ago, it used to be that ARM was like more accelerator, more better, and Intel was like more cores, more better. But now it's totally flipped. ARM is like more cores, more better, and now Intel is like more accelerators, more better. And if you've made it this far, you probably have sat there and been like, hey, I have rage written things in the comments. Why have you not talked about AMD yet? We're going to get to that right now. Now, AMD is actually in a really kind of interesting space. Because they're using TSMC, they can actually get higher core density than Intel can, just because you know, they're a process ahead and they've been doing this chiplet thing for a while. So AMD has said that Genoa will go up to 96 cores. They have another option, Bergamo, that we'll talk about, and we've had a video on before, but we'll talk about that really briefly. But the idea is that their next generation platform will have their mainstream Genoa part. That will be a 96 core part. Now, what AMD has actually done is they said, hey, you know, this generation, we're going to give you things like, we'll give you AVX 512, so if you have HPC applications, that'd be a nice boost there. We've already looked at some of the performance benefits you get from that. And then also we're going to do some things like maybe we'll look at some AI stuff, or, you know, we're going to start looking at adding some of that acceleration. So what AMD's strategy is, and it's kind of interesting on the acceleration side, is that they're basically saying, hey, Intel, why don't you go first and you go kind of get the market used to having this acceleration. Then once the software support is there, then we're going to come in and we're going to go and add some of that thing. So now that you've done AVX 512 and people are actually using that, we're going to go start supporting that in our chips so people can buy our chips and leverage that software uplift or software work that they did previously. So that's like basically the AMD acceleration idea. And if you're wondering what they're doing around crypto and like offloads and all that kind of stuff, well, there's Xilinx, but then the other big one I think is really going to be Pensando, because that kind of fits the best in the server space. But at the same time, that is what AMD is doing. So AMD is not necessarily going to have more cores than all of the ARM players. Now, they're going to be very competitive because an ARM core today is pretty similar to like an x86 core with its SMT, so it's like kind of more like a thread on the x86 side. And so if you know, if just kind of give you an idea, the Ampere Ultra Max, the way I kind of tell people to kind of think about it is an Ampere Ultra Max at 128 cores is somewhere between like a 64 core AMD Milan, so EPYC 7003 series CPU, and a 7003X, which is the Milan X part with the extra 3D V cache. That would be like, you know, the Ampere Ultra Max is like somewhere in that range. The easy way, it's not precise, but the easy way to kind of just conceptualize it is an AMD thread is about equivalent to an ARM core. This doesn't always hold, but it's just kind of at a full chip level that's not too far off of where you get. Now, because AMD is also trying to be a general purpose HPC processor, and they are starting to add these accelerators in, that will be another adder on some workloads. But a lot of things like, you know, if you look at like Spec Int, like they're not going to look at those accelerators, right? So like both Intel and AMD are building like all this technology into their chips, and like Spec Int is like, yeah, we we don't care. So you can go build whatever the heck you want, but you're just kind of wasting, if you're trying to get the best spec in score possible, you're just kind of wasting silicon on this. But in a lot of workloads, those are used, and it makes their processors very high performance and very general purpose. But the other thing to remember though, is that if you have an AMD core and you're roughly thinking like a 64 core AMD processor is equivalent to a 128 core ARM processor, well, if you're licensed on a per core basis, you would be absolutely crazy right now to use ARM. Instead, you're much better off using AMD or Intel. And Intel is even kind of taking that a step further, because it's saying like, hey, we can just take all of that, if you're being licensed per core, we're going to take all this like common stuff like encryption and compression, and we're just going to go put that on accelerators. So we're not even going to touch your cores basically for that. And that gives you more cores, and you're not spending many, many thousands of dollars on licenses, right? So I guess if we have ARM that's more cores, more better, Intel that's more accelerators, more better, AMD is kind of somewhere in the middle, like more in the middle is more better. I don't know, but that's basically the way that I'm looking at all of the different processors. Now, we do just want to quickly mention that all of these vendors are going to have absolutely massive jumps in core counts in this next generation. And I do not expect that that was going to slow down. I mean, there's a lot of competition in the market, and so that is going to accelerate the core count growth. One of the other things to remember, though, is that AMD and Intel, they totally know about this whole like cloud providers want X performance per vCPU. They totally get that, right? So they need to go figure out a way to cram more cores onto a chip and sell those. And so you see things like Intel Sierra Forest, which is going to be a little bit later, but also in this next generation socket, we'll have AMD Bergamo, and that will really go up to 128 cores and more threads. And so that's basically what AMD is doing. They're saying, hey, we can actually build something that's a little bit better for the cloud, but we're still going to have a lot of our kind of roots, but we're going to kind of build something that's a little bit more cloud friendly. This is something that, I think all of the big vendors know is happening. It's just basically like the ARM vendors are like, hey, our architecture is like perfect for this right now. And these guys, they have to go build something new to even come and compete. So that's what we're going to go do. Anyway, I know this is a lot of me just talking, but the reason is I just wanted to kind of get out a perspective, and hopefully, you're doing something else and just listening to this in the background. But the idea was really to just kind of get a couple key concepts to you. Really, ARM, more cores, more better. Intel, more accelerators, more better. AMD, more in the middle, more better. And then also just what the impact of all these new really, really high-end processors are going to have on the market. We are going to get back to a lot more of our review content pretty soon, but frankly, I'm traveling, and I'm only going to be in Austin for I think like 7 days in the next month because I'm going to be traveling so much. So this was kind of a video that we could do without having to go do all of the B-roll and all that kind of stuff. So it's a little easier to produce. So hopefully you guys like this as well. Usually these pieces, by the way, actually do come true, and they have in the past. So hopefully you learned something and you'll get to use it over the next couple months. And if you did like this video and you want to see more, well, why don't you give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.